Hello, I'm Norianne Sharp. Today, I'm going to talk about displaying and summarizing categorical data. Let's review some of the important points of the chapter. We will look at frequency and relative frequency tables, bar charts and pie charts, contingency tables, marginal and conditional distributions, and bar charts for two variables. Remember that a categorical variable is one whose possible values are categories, and categorical variables have no units. Suppose the possible values of my variable are blue, red, and green, like the phone color variable in this table. That's clearly a categorical variable. However, the variable price has units, so it's clearly quantitative. So those two are pretty clear. But when the possible values of a variable look like numbers, like these model numbers, we have to ask ourselves, how are we treating them? Are they really numbers, or are they just numerical values acting as names to describe categories? Answering that question will tell us whether we're looking at the variable as categorical or quantitative. One of the first things we do with a categorical variable is to count the number of cases in each category. If there aren't too many different categories, we can display the distribution as counts in a table. We have a choice of displaying the counts or the percentage in each category. Here's a frequency table for the distribution of ways in which visitors reached a sales website. The frequency table shows the 6 possible responses and the count for each category, as well as the percentages in the last column on the right. Data are almost always easier to understand in a picture. The bar chart makes it very clear that the most popular paths were from Google and Direct. We can also express the counts as percentages to get a relative frequency bar chart. Note that the shape of the bar chart does not change. Here is a pie chart of the same data. Pie charts are useful if you want to see percentages of the whole easily, but they are less effective for comparing counts across groups. For example, it's hard to see from the pie chart that there were more accesses from all other search engines than from Yahoo, something we could see clearly in the bar chart. Let's look at another example that has 2 variables instead of 1. Surveys frequently ask consumers about food and product preferences. We will use data from a 2005 survey that asked consumers worldwide if they agreed with the statement, "I have a strong preference for regional or traditional products and dishes where I come from." Note that you should always identify the who, what, where, when, why, and how for each data set. Let's look at a contingency table. Because we have 2 variables, we have both rows and columns, and we can choose to report the counts or percentages of the entire table. The total row and total column show the marginal distribution of regional preference and country of origin of survey respondents. Here, in the second table, are the percentages of the entire first table. So we can see from the total column that the distribution of country of origin is approximately even or uniform, all approximately equal to 20%. Of course, that's just because here the survey sampled similar numbers of people in each country. From the total row, we see that the majority of respondents agreed with the statement about regional preference, since more than 50% of the respondents are in the first 2 columns. We can also display the column percentages or row percentages. Both of these show conditional distributions because each row shows percentages of respondents who satisfied the condition of being in a specified category. Here, we have the row percentages for India and the UK. Looking across these rows, we see that a much higher proportion of Indian respondents agreed with the statement on regional preference of products than British respondents. Side-by-side bar charts make direct comparisons between the counts easier. Here is a side-by-side bar chart showing the same row percentages we just saw in the prior table. It is easier to see the difference in the distribution of respondents from India and from Great Britain in this chart. Another option is a stacked or segmented bar chart, where the conditional distribution is shown within each level of the other variable. Here's an important thing to look for whenever you look at two variables at the same time. If the two conditional distributions look roughly the same, we say that the variables appear to be independent. If not, they are not independent, and we say that the variables are associated or related. You can look either at the contingency table or side-by-side plots or stacked bar charts to see this. We'll make the definition of independence more formal later, but for now, it's clear from our displays that country of origin and regional preference are associated. The question of whether or not two variables are independent will be a key concept throughout this course. Well, that wraps up our summary of this chapter. Today, we have examined frequency and relative frequency tables, bar charts and pie charts, contingency tables, marginal and conditional distributions, and bar charts for two variables. Categorical variables are commonly found on business surveys, so it's important to understand how to treat them. Thanks for watching.